Hey there, my name is Rohit Kumar, and today we are going to discuss another very important convolution network named VGG. So let's start with the basic definition and the kind of key concepts from Wikipedia. So Wikipedia says that the VGG, this term, this acronym stands for Visual Geometry Group, which is a kind of academic group focused on the computer vision study at Oxford University. So, usually every group or something that starts with the same sort of interested people, and they form the group to have the focused study on a particular concept, and that's why usually the kind of academic groups get formed. So, similar way at Oxford, they formed this group, and this acronym came up with VGG. Now, when we say this particular VGG, so obviously, like I usually say that with respect to any particular, doesn't matter whether it's a network, any concept or something like that, some data set or something, then there must be some base paper or some focused study paper. And if you find that, then it becomes very easy to understand that particular topic, and obviously the straightforward journey to the future topics and the related concepts. So obviously with respect to VGG also, you have the very deep convolutional networks for large scale image recognition. This paper, if you go through, then you'll find most of the things that those are related with BGG and the key concepts which are working behind this particular network. So in this particular work, what the authors are saying that they investigate the effect of the convolutional network depth on its accuracy in the large scale image recognition. Okay. And the point is that every work is going to contribute something. So they say that the contribution is a thorough evaluation of networks of increasing depth using architecture with a very small convolution filters, 3 by 3. Okay, so these are the sort of things where the authors are claiming their work, and in this way you can recognize that what is the importance of this particular paper. But when particularly coming to the VGG, then it's a classical convolutional neural network architecture, and it is based on the analysis of how to increase the depth of similar to sort of network. Usually, the 3 by 3 filter, as authors have already told, I showed you, the network is characterized by its simplicity. So, in this way, the other components being the pooling layer and the fully connected layers. So these are the things which are related. Now coming to the competitors, because every sort of network is going to have some sort of competitors or the similar sort of networks. So like VGG, we have already covered a very popular network which is ResNet. So VGG is closely coming as a competitor to ResNet. Then we have the DenseNet, then VGG 16, and LXNet, MobileNet V2, and similar sort of other multiple networks are there. So these networks are going to perform similar sort of tasks, like they might be used for image recognition, they might be used for the normal classification work, they might be used for object detection, super resolution, the kind of segmentation, quantization, etc. So all these sort of works you can do with these similar sort of networks, and ultimately the power of AI is going to drive the works done. So the only thing that, as I told you, that you should start from a very good research work or very good paper where you can find the authentic information. Because usually there are so many things which are available on internet, but there might be multiple issues, multiple errors. Obviously, the human errors. And in my videos also, there might be multiple issues. I'm not saying that everything is gonna right. So there might be some human errors, but just to avoid those errors, you are supposed to take the example or the base of a fully proved or at least the highly proved work. So usually some research paper, when it gets published, it goes through a scrutiny process. Multiple reviewers or a team of editors go through it, and they see that substantial quality is present over there, then only it is accepted for publishing, or it is accepted in some online repository like other. So in this way, this particular work which I showed you, this particular work is going to discuss the kind of things which are related to the VGG, and the people, the authors, they are also saying that they have made the two best performing convolution network models publicly available to facilitate the further research. So these models might be used, and specifically these models are working fantastically because so many research papers are available based on VGG. If you go through the Google Scholar, then you'll find number of papers based on VGG. And coming to the specific details, so let me tell you that there are quite very fantastic topics and the research articles over there. Like one is you only look once, the unified real-time object detection. Quite a wonderful title. Secondly, the fully convolutional networks for semantic segmentation is also there. So usually people don't talk much about semantic research, but it's a widely popular field. Then coming to the another work, which is the CBAM, convolution block attention model. And the other thing include the object detection at 200 frames per second. Usually we have the 25 or the 30 frames, you do know. But when you are recording at 200 frames per second, so you can think about the kind of accuracy and everything means over there. So my point is only this, that number of papers when are available over there, then again it becomes difficult to find the fundamental knowledge about something. So go through this particular work and then as this particular paper is shown. So if I let you allow, means if you allow me to open the work, then I will show you. It might take some time. Yeah, open. Okay, so here you can see that it published as a conference paper in ICLR 15 and bit old paper, but still a lot of details must have been there. So starting, they are starting with the normal convolution networks, and then they are discussing its success and all the related things. Then the commodity and the computer vision field, how it is being used. Coming down, the discussed architecture configuration, and they have done the discussions based on the convenient configuration. Then down there, they have given the classification framework with respect to the training, testing, and the implementation details. Then the classification experiments they have shown and discussed with respect to single scale evaluation and the multi-scale evaluation. So these are the kind of things which are available over here. And if you see, then they have given the comparison of the state of the art ILS VRC classification. In ILS VRC classification, and finally they have concluded the work. So quite a straightforward paper. You can find a lot more detail, and particularly coming to the specific things which are related to this particular work. So let me tell you that some of the related components are the convolution, then dense connection, the pooling, activation function, in particular the ReLU, and some of the related concepts like softmax and dropouts, etc. are there. So all these terms, obviously, any person who is working in the field of AI or deep learning, they must have been familiar with all these things. Still, if you are not familiar, then particularly go to some basic AI introductory site or the crash course. And additionally, if you are particularly interested in VGG, then for which I made this particular video, then go to this particular research paper and study it thoroughly. Lot of authentic details you'll find over there. So that's all from my side for this particular video. If you didn't like anything, please do comment below and criticize. I will definitely try to incorporate your suggestions in my coming future videos. Thanks for watching. Happy learning.